Hello everyone. So after a long time, I'm back with the new videos. We'll start with grade 10. And I know you people just were waiting for the video. So I'm just looking forward again your support. Kindly subscribe, like, and watch the videos. Spread it as much you can and do show love to me. Thank you so much. So let's start now. Today we are going to start the topic that is from grade 10 physics, magnetic effects of electric current. And as the topic is not new to you people, you have some idea how to do that. So let's see. There are some topics, subtopics what we are going to cover in this video, that is magnet and its property, magnetic field, methods to draw magnetic field lines, and the properties of magnetic field lines. And in upcoming video, we'll cover the rest of the topic as well. So let's start, friend. Magnet. What do you mean by the magnet? Magnet, as we have seen, we all play with magnet. We have played with magnets. So magnet that attracts the magnetic material or such kind of material, like you can say, which is made up of, you can say iron, nickel, cobalt. These are called the magnetic materials which get attracted towards magnet. Not only magnetic material, but yeah, another magnet also get repel or attract towards the one magnet. Remember, like poles repel, and unlike poles, they attract each other. So that we are quite aware. Now there are some properties also which surprise us that okay, this has happened. That when you see that, you can try at home yourself. If you take a current carrying conductor, and if you keep it and you keep a compass with you, so when you keep the compass, what happens that you will feel the deflection in the compass, right? Means they just take a simple circuit, keep it on the table anywhere, and take a magnetic compass, and if you keep it, you will watch it. What you will watch, that what you observe in that magnet compass will deflect as soon as the current is flowing. And as you stop flowing the current, what happens then? It will not behaving as a magnet. So what do you understand by this? You can say that concludes what? It concludes that if a current is if the circuit is having the current, that can produce magnetic effect around the circuit as well. So this is called what phenomena? That is magnetic effect of electric current, that we call it, right? So there are some properties of the magnet. So in every magnet, we know that there's a two poles, north and south poles. We have same poles, as I've just told you, like poles, same poles, they repel each other. Unlike one, they you can say attract each other, like north pole. So you can say that south, north, like one, they will repel each other. And if you have a magnet and it is suspended freely in the, you can say, so what will happen? Always the line in this direction, north or direction, that always direct towards north or direction. That is also one of the nature that we have read it earlier as well. So this is what the shape we have, which only we have seen. It is not a new thing. That is very common. That is called the bar magnet. And the bar magnet has two poles, as you can see here, north and south one. This is a kind of rectangular, and we have north and south is also engraved on that magnet. So this is made up of iron steel, that are magnetic material, and that you can see that is available in the rectangular shape. You will be surprised, or I think some of you are aware of also that the earth is also have the magnet, and that's why actually the compass needle show the direction. Like you can say compass is also used for navigation to find the direction as well. The earlier time, you know, the travelers and all, the people who used to go to find the new places and all, they didn't have any option. They used this compass and all, right? So the earth is also having that, you can say, magnet, and because of that we can see that magnet always aligning north direction and all. But what earth's poles, magnet's poles, and the geographical poles, what we are aware, like on the upper side we used to see the globe, that is a north pole, and the downward is a south pole, but the magnet is the, you can say, shows the opposite poles. The geographical north is what? The earth's magnet south pole. The geographical south of earth, that shows what? The earth magnet north pole. So this way, that's why because like if you say that the North Pole is one there where the Earth magnet South Pole is existing. That's why the magnet will get attracted and will show the north in the compass. Compass में North Pole not दिखता है, right? Why? Because Earth का South Pole कहाँ पे है? Towards the you can say geographical North Pole. So that's why it is having. That's why our compass needle shows its effect. We see it aligned always in north or direction when it is freely suspended. With the last property we have read it over here. The next is what? That is magnetic field. So what is magnetic field? Obviously, if you have a magnet, आपके पास एक मैग्नेट रखा है, उसके आसपास आप कुछ चीजें रख दो which are magnetic material, और आप another compass रख दो, what will happen? Then you will see here, what you will see here, that the area, the space, the region around the magnet, if we have, so what you will observe over there, that you will observe that around there is the influence of the magnet, where it can show its effect, its magnetic force. That area around the magnet, the space around the magnet, where it can show its influence, that area is known as magnetic field. वो उतने में उसका जो अपना effect show कर रहा है, उतने में वो उसका effect आ रहा है, right? वो उसका क्या होता है, उसको magnetic field बोलते हैं. And how can we see that? You can see lines. You are able to observe on the screen. What are the lines? Lines are what? They are showing the magnetic field lines. The lines means we can say that ये उतना area है जहाँ पे magnet जो रखा है वो अपना influence show करेगा, right? ये वो वाला region है. That is called the magnetic field, and the lines are known as magnetic field lines. We can say that, right? So there are some properties also for these magnetic field lines that we will just we will read, or I will tell you. Like you can say that we can see near the poles, the lines are more crowded as compared to the lines which you can see away from the poles, right? So this is what you can say that here, what you can observe here. So जहाँ पे जितना crowded आपका lines होता है, वो क्या होता है, उतना ज़्यादा strong magnetic field आता है. जितना कम लाइंस होंगी, लाइक अगर वो टू मैग्नेट्स है और एक में बहुत क्राउडेड लाइंस आ रही है, थोड़ा सा हल्का लाइंस आ रही है, तो से दैट क्राउडेड लाइंस में मोर स्ट्रॉन्गर मैग्नेट we do have, right? That we can also see, we can also observe in that. And then you can see that so as stronger the magnet is there, the more crowded lines will be then, or they are and one more thing, what they are moving from north to south direction. The direction is from north to south, that we can read it like that. Okay, so let's move further. Yeah, अभी how do we know that? हमें कैसे पता चलेगा कि magnetic field line उसी shape की बनेगी? How can you do that? That you can do yourself. Take a white sheet, keep on a table, take a magnet, bar magnet, keep on that white sheet, and just take iron filings. That is very, very small. Like you can say the dust, iron dust, you can say that. So when you just spread around that the magnet on the white sheet, then we'll see that after some time they'll arrange themselves in this shape, and you can see the shape is this. If you observe it, you can see carefully, the shape is resembling with what? With that last picture what I've shown you, the direction. This is how you can find out yourself कि हाँ यही वाली इसी तरह से आपकी shape बन रही है, हाँ ठीक है? So that you can also judge over here. Okay, the next is another method. There are two methods actually. If you just go through NCERT book, it is given in that as well. So if you see that the one method, you just sprinkle, you just spread that some iron filings around the magnet, and you will see the effect. The second is what that you can see. If you take a compass and again the white sheet, keep the you can say magnet over on that. Take a pencil, take a compass, small compass. Now what do you have to do? If you see in the picture as well, if you keep the compass is also north and south one, right? That we are aware of that. Now what we have to do, you have to keep the compass near the north pole of the magnet, and it will align in the one of the direction. ठीक है, वो जहाँ पे भी उसको align करेगा, आपको क्या करना है, सिर्फ वहाँ पे आपको dot लगाना. You have to put a dot over there. Now take the compass. Another way you put the dot, then again you keep your compass there. Then it will if you keep repeating your you can say procedure, the method, what you will do, you will observe, you will just get the same method, but it will just you can say time taking method. It will thoda sa time lagega, and your method should be correct, and only you will get the result. Iron filings is the easiest one that you can find easily. You can just get the result easily. So this is one of the method again. Yeah, then these are the some of the properties what I was talking about. Some of them already I have discussed with you, I told you. So what is that? Magnetic field lines result in the formation of continuously running closed loops. मतलब वो आपके break नहीं होंगे, वो एक continuously आपके circles बनते हैं, आपके loops बनते हैं, not a perfect circle. They just form a loop. It is just showing. And the direction that you can show by convention. Actually, it is a conventionally what we are showing the direction. So it starts at North Pole and it ends, it's completes its loop to which pole? South Pole. So north to south आपका दिखाते हैं, but inside the magnet it is उल्टा, it is a continuous loop. बाहर वो north to south दिखा रहा है, तो अंदर वो क्या दिखाएगा? South to north दिखाएगा, तो वो complete एक loop बन जाता है, right? टेंजेंट हम लोगों ने 9th में पढ़ा, आपने मैथ्स में पढ़ा होगा. द टेंजेंट इज व्हाट, अगर एक सर्कल है, रेडियस पे जो परपेंडिकुलर लाइन बनती है आपकी, दैट इज व्हाट, दैट यू कॉल इट एज टेंजेंट, राइट? अगर आपका एक लूप है जो डायरेक्शन शो कर रहा है, मैग्नेटिक फील्ड की जो डायरेक्शन शो हो रही है आपकी, आप कहीं पे भी एक टेंजेंट जो आप बना रहे हो, व्हाट इज दैट? दैट इज अ डायरेक्शन ऑफ मैग्नेटिक फील्ड एट दैट पर्टिकुलर पॉइंट. Now what you can see there, if I just show you that picture again here, this one picture, it will say, you can see this is what the needle of compass needle, you can say जो compass है आपको जो needle है, that is showing a kind of tangent only. So आप थोड़ा सा आइडिया लगा सकते हो, ये अब जब आप एक लूप है, इस पे थोड़ा सा टेंजेंट जो बन रहा है, परपेंडिकुलर लाइन बनेगी to the radius, so it is showing the direction of the magnetic field along that, you can say direction, मतलब उस पॉइंट पे वो आपका डायरेक्शन शो कर रहा है. So tangent shows what the direction at that particular point of that magnetic field, right? The third one, the greater, that I told you, जितनी ज़्यादा crowd line, जितनी ज़्यादा denser line होंगी, crowded lines होंगी, means the magnetic field is as stronger as the magnet is. जितनी कम होंगी वो उतना weak आपका magnet है. Main and very important, और ये 1 मार्क के अंदर क्वेश्चन आता है, why don't two lines, two magnetic field lines intersect each other? What is the reason behind that? The reason behind that is what? That they never intersect. The magnetic field line never intersect each other. Why so? Because जहां पर भी अगर दो लाइंस intersect करती हैं, तो means उस पॉइंट पे आपको दो डायरेक्शन दिखाएगा. जब आपको वो क्रॉस करेगा, एक पॉइंट है जहां पे आपको दो लाइंस क्रॉस कर रही है, तो एक पॉइंट पे आपको दो डायरेक्शन दिख रही है. ठीक है, कैन यू सी माय फिंगर? तो दो डायरेक्शन आपको जो दिखेंगी, इट मींस एक पॉइंट पे आपको दो टेंजेंट मिल रहे हैं या दो डायरेक्शन मिल रहे हैं. हाउ कैन बी पॉसिबल? एक नॉर्थ पे एक ही साउथ होगा ना. हाउ कैन बी पॉसिबल कि एक नॉर्थ है तो उसके दो साउथ डायरेक्शन है? इट कांट बी पॉसिबल, राइट? So that's how it happened. Magnetic field direction associated with the same point, which does not occur. If the compass needle is placed at that point, it will show two different directions. So दो डायरेक्शन जो दिखाएगा वो पॉसिबल ही नहीं होता actually. That's why never ever two lines will never intersect each other, right? This is what the very basic, very brief of the initial introduction. मान लो magnetic field strength थोड़ा सा आपको terms aware हो गया. So in the upcoming chapter we'll do much more topics about the same. I hope you like the video. Thank you so much. Kindly do subscribe, support, spread it. And now one more thing, there's an assignment. Kindly just don't forget to attempt this assignment based on the topic what we have done in the video. So kindly do it, and we'll wait your comments. Any problem, anything, you just post in the comment. Thank you so much. Bye, take care, and we'll see you soon. Now we'll try to be regular. So you do message me also. Just drop the message DM. What kind of chapter, what topic you want me to make more. Thank you. Bye, take care.